Hello friends, good morning. Welcome to my channel Belagali's classes. Yes my friends, we are doing with differentiation. Completed what? The first derivatives of algebraic functions, after that trigonometric functions, exponential functions, logarithmic functions, then the related examples based on those, especially examples based on product and quotient formula, UV and U by V formula derivatives. Then another very important topic in differentiation is derivatives of composite functions. My friends, I referred that composite function as what? It will control the entire differentiation, my friends. Therefore, it is just like heart of the calculus, differential calculus, my friends. Yes, we have done with what? Derivatives of composite functions. After that, derivatives of what? Implicit functions. One part is very important. In that case, we are going to study what? Derivatives of a function of y with respect to x. Derivatives of function of y with respect to x. I told while differentiating function other than x. Function other than x means what it is? It is a function of y. My friends, here first you have to differentiate this function of y with respect to y, then y with respect to x. Remember, if you have the derivatives of what? Other than y, my friends. Other than y means anything. Y square, y cube, y to the power n, sin y, cos y, tan y, sec y, log y, e to the power y. In all these cases, my friends, first you differentiate that function of y first with respect to y, then dy by dx. In case of what? Function of y, this is must, into dy by dx. My friends have taken one example here. Derivatives of sin y with respect to x. Derivatives of sin y with respect to x. I told first differentiate sin y with respect to y. Sin y with respect to y is cos y. Then y with respect to x. I told my friends, if this angle is other than x, write its derivative. Is it x? No, it is y. Then you have to write its derivative, dy by dx. Like that, my friends, sec. What is the derivative of sec? Sec into tan. The first with respect to y. Then y with respect to x. Like this, my friends, it is implicit functions. Yes, my friends. I want to use these trigonometric identities. These trigonometric identities we done at 10th standard. Sin square theta plus cos square theta is 1. So cos square theta, shift that side. Then what is cos theta, my friend? Cos theta is square root of 1 minus sin square. Like that, 1 plus tan square is sec square, or sec square is 1 plus tan square. Cosec square is 1 plus cot square, or 1 plus cot square is cosec square. Yes, my friends, these are the basic trigonometric identities that we are going to use while finding the derivatives of what? Inverse trigonometric functions. Inverse. This also we use in what? Inverse trigonometric functions. Yes, my friends. After completion of what? Implicit functions. Derivatives or differentiation of implicit functions. Next comes differentiation of or derivatives of inverse trigonometric functions. Yes, my friends. It is derivatives of inverse trigonometric functions. While finding the derivatives of inverse trigonometric functions, we need their definitions, my friend. This inverse trigonometric functions already we have studied in detail. That is why normally first to start with I do what? Inverse trigonometric functions, because its use, the formula, everything is very much useful. Therefore, I will start with inverse trigonometric, then calculus. Yes, my friends. See the definition. Definition of what? Inverse trigonometric functions. Under the given domain and range of IT of inverse trigonometric functions, by definition we have, if sine inverse x equal to y, then x is sine y. Under the domain and range it is written. This itself, you know the domain and range, I don't want to repeat it. Already we have completed what? ITF. Yes, my friends. If sine inverse x equal to y, then x is sine y. Conversely, if x is sine y, then y can be written as what? Sine inverse x. Sine taking this side is sine inverse taking this side is sine. Yes, my friend. Similarly, cos inverse x equal to y gives what? X equal to cos y. Conversely, x equal to cos y gives what? Y equal to cos inverse x. Bring cos this side, cos inverse. Bring cos inverse this side, cos y. You know this, all these definitions. Similarly with tan inverse, cot inverse, sec inverse, cosec inverse. Everything with what? Definition of what? Inverse trigonometric functions. Definition of inverse trigonometric functions. Yes, my friends. Now I do one by one. While doing, I don't want to do all 6 man. There are 6 trigonometric functions. What are there? One is sine inverse x, friend cos inverse x. Third is tan inverse x, friend cot inverse x. Fifth, sec inverse x, friend is cosec inverse x. 3 pairs, sine inverse cos inverse, tan inverse cot inverse, sec inverse with cosec inverse. Among the 6, I do the 3, sine inverse, tan inverse, sec inverse. As you know, the derivatives of the trigonometric functions that starts with letter C have negative sign. For example, derivative of cos x minus sin x, derivative of cot x minus cosec square x, derivative of cosec x. What is the derivative of cosec x? Minus cosec x into cot x. Therefore, the same thing. What is same thing? Derivatives of a trigonometric functions that starts with letter C have negative sign. The same tempo is continued in case of what? IT of inverse trigonometric functions. So here also derivative of cos inverse x, cot inverse x, cosec inverse x, all the 3 starts with letter C. Therefore, their derivatives they have what? With a negative sign. Yes, my friends, we will see one by one. First, my friend, opening batsman is what? Derivatives of sine inverse x with respect to x. Let y equal to sine inverse x. Apply the definition. Sine inverse taking this side is sine y equal to x. Sine y equal to x. Yes, this is our friend now. Differentiate with respect to x. Derivative of LHS, which is sine y equal to derivative of RHS, derivative of x with respect to x. My friend, it is not x, it is a function of y. First differentiate sine y with respect to y. Derivative of sine y with respect to y is what? Cos y. Then what is this other than x? Write its derivative. dy by dx. Now what is the derivative of x with respect to x is 1. This cos y I want to substitute. I told here in the beginning itself. What is cos theta? Square root 1 minus sine square theta. Cos y square root 1 minus sine square 1. The same thing I have written, my friends here. This cos y can be written as square root 1 minus sine square 1 into dy by dx equal to 1. So, what is the value of sine y? Sine y is x, my friend. Sine y is x. Substitute. Yes, because sine y is x. Substituted. Then you want a dy by dx. Push it down here. 1 minus root 1 minus sine square x. Therefore, my friend, if y equal to sine inverse x, then dy by dx is 1 upon root 1 minus x square. Substituting y equal to sine inverse x, that is derivative of y means sine inverse x with respect to x is 1 by root 1 minus x square. It is easy to remember. Sine inverse 1 by root 1 minus square of this term x square, 2x square, like that, my friend. Square of this term. Yes. Similarly, I told already, derivative of cos inverse x starts with letter C, has a negative sign. The only difference of this derivative of cos inverse x is same as sine inverse with sign change. Why? Because of cos. Because of cos. What is the derivative of cos? Minus sign. Yes, my friend. This is sine inverse x, that is cos inverse x. Yes. This is one pair. One pair. I write here. It is derivative of. I write capital D. Derivative of sine inverse x is 1 by root 1 minus x square, and derivative of cos inverse x. Yes, my friend, the only change is instead of plus 1, it is minus 1. Yes, my friends, this is one pair, sine inverse, cos inverse. Yes, my friends. See for a minute. Yes, my friends. I hope understood. It is clear. First, I will explain once again. We wanted the derivative of sine inverse x. Let y equal to sine inverse x. Apply the definition. Sine inverse taking this side becomes sine y equal to x. Now it is an implicit function. We can differentiate it. Differentiate with respect to x. Derivative of sine y, LHS. Derivative of x, RHS. Sine y, other than function of x, it is a function of y. First, with respect to y, derivative of sine with respect to y is cos y. Other than x, it's a derivative. dy by dx equal to derivative of x is 1. Cos y, identity, trigonometric ratios explained, my friends. 1 minus sine square y. What is sine y? X. It is root 1 minus x square into dy by dx equal to 1. So dy by dx is 1 upon root y sine inverse x. Therefore, my friends, derivative of sine inverse x with respect to x is 1 by root 1 minus x square. Similarly, yes, you go with all the steps like this. C means negative sign. Same, both are same, opposite in sign, plus minus, my friends. This is the first pair, sine inverse x and cos inverse x. X, my friends. What is the next pair? Next pair is tan inverse x. Yes, my friend. Next pair is tan inverse x and cot inverse x. Yes. Next is derivative of tan inverse x with respect to x. Next, my friend, third is derivative of tan inverse x with respect to x. Yes. Same method. Let y equal to tan inverse x. Let y equal to tan inverse x. Then, by definition, bring tan this side. tan y equal to x. Now it is implicit. Differentiate with respect to x. Differentiate with respect to x. Derivative of LHS tan y with respect to x equal to derivative of RHS with respect to x. Now you know the derivative of tan sec square y other than x into dy by dx equal to derivative of x is 1. Yes, my friends, already I have written about the identities. 1 plus tan square is sec square, or sec square is 1 plus tan square. Yes, my friend. Sec square is 1 plus tan square. 1 plus tan square into dy by dx equal to 1. Now you know the value of tan. Tell what is tan y is x. Substitute. Now it is 1 plus x square into dy by dx. 5. Tan y is x. Therefore, solve for dy by dx. So, dy by dx is 1 upon 1 plus x square. Dy by dx is 1 upon 1 plus x square. But what is y? Y is tan inverse x. Y is tan inverse x. Therefore, y means tan inverse x with respect to x equal to, tell friend, this is 1 upon 1 plus x square. So, derivative of tan inverse x is 1 upon 1 plus x square, my friends. This is the third one. Similarly, friend, what is it? Derivative of cot inverse x with respect to x. Tell my friend. This is starts with letter C. I told sign change minus 1 upon 1 plus x square. See how they move. Derivative of tan inverse, cot inverse, it is same. As it is a C, its sign is minus. They differ in only sign, that is with a negative sign. It is easy to remember which is minus. Minus is what? Derivative of cot inverse. Why? It is an inverse trigonometric function, starts with letter C, my friends. Letter C. C for 1 minute. C for 1 minute. Yes. My friends, I will explain it. Next is derivative of tan inverse x with respect to x. What is the method? Let y equal to this. Apply the definition of inverse trigonometric functions. Bringing tan inverse becomes tan. Our friend, differentiate. Derivative of RHS, derivative of LHS, derivative of RHS. Tan sec square y into derivative of y with respect to x other than x. Y with respect to x. X with respect to x is 1. Sec identity 1 plus tan square. Tan, the value of tan is x. 1 plus x square into dy by dx equal to 1. Therefore, dy by dx equal to 1 upon, bring down 1 plus x square. But what is y, my friend, is tan inverse x. Therefore, derivative of tan inverse x with respect to x is 1 upon 1 plus x square. Similarly, derivative of cot inverse x is minus 1 because of C. Minus 1 upon 1 plus x square. Yes, my friends. Yes, my friends. This is derivative of tan inverse x which is 1 upon 1 plus x square, and derivative of cot inverse x, it is minus 1 upon 1 plus x square. Minus 1 upon 1 plus x square. Yes, my friends. Next is sec inverse and cosec inverse. Sec inverse and cosec inverse. Cosec inverse. Yes, my friends. Okay, this time I do instead of sec inverse, ITF starts with C, cosec inverse I do, my friends. Yes. Derivative of cosec inverse instead of sec I do cosec inverse with respect to x. With respect to x. Let y equal to cosec inverse x. Then bring this side cosec y. Cosec y equal to x. Differentiate with respect to x. Yes, my friend. Derivative of cosec y with respect to x, RHS derivative of x with respect to x. Again, my friends, this c gives again next c is also minus. What is derivative of cosec? Minus cosec y into cot y. Again, what is this? Other than x, right? It's a derivative. Derivative of y with respect to x. Derivative of y with respect to x equal to derivative of x is 1. X is 1. See, my friends, here. What is cosec square? Cosec square theta is 1 plus cot square. I write once again, my friends, here. Cosec square theta is 1 plus cot square. 1 plus cot square. Therefore, you wanted what? Cosec there. Cosec theta. It is square root 1 plus cot square theta. Yes, my friends. Next, you wanted cot, the value of cot also. See, from this. What is cot square? Cot square theta is, bring this side. It is cosec square theta minus 1. You wanted cot theta. Cot theta is what? Square root cosec square minus 1. Yes, my friends. We want to use these values. One is cosec, another is cot. Yes, my friends. Explain. It is with the help of what? This third identity of trigonometry. SSLC 10th trigonometry, my friends. Now I will substitute. This is minus. What is cosec? What is cosec? Cosec is, keep it as it is. Why we wanted the value of cosec is, we wanted it. Cosec y. But we have to transfer this cot in terms of cos. What is cot in terms of cosec? Square root. My friend, this is cot is cosec square minus 1. This is minus cosec y. What is the value of cot in terms of cosec? Given there, it is cosec square y minus 1 into dy by dx. Into dy by dx. This, my friend, equal to 1. Now you substitute. Yes, my friend. What is cosec y? Is x. Put it. It is minus x into square root. What is cosec? X square minus 1. X square minus 1 into dy by dx equal to 1. Therefore, dy by dx equal to it is 1 upon this. That becomes minus 1 upon x into square root x square minus 1. X square minus 1. Tell my friends, what is y? Y is cosec inverse x. Therefore, derivative of cosec inverse x. Cosec inverse x with respect to x is, it is minus 1 upon pi c minus 1 upon x into root x square minus 1. My friends, it is a proved result. Just 1 minute to observe it. 1 minute, observe it. Similarly, my friend of this cosec inverse is derivative of sec inverse x with respect to x. My friends, I use the word friend of cosec inverse x means its derivative is same with plus sign. Why? It is not c. If it is c, minus sign. Other than c means 3. Sine inverse, tan inverse, sec inverse. They have positive sign, same with positive sign. Yes, my friend, this is the third pair. Yes, my friends, observe it. Try to understand. Yes, my friends. Once again, see. We wanted derivatives of cosec inverse x. Let y equal to. Bring this side. Differentiate with respect to x. First with respect to y, then y with respect to x. Derivative of x is 1. You know, explained there. Cosec is cosec itself. Cot you must convert in terms of cosec because we know the value of cosec. Cot. Root cosec square y minus 1 into dy by dx. Its value, my friends, x. This is x. Root x square minus 1 with a negative sign into dy by dx equal to 1. Bring down dy by dx. 1 upon minus is minus 1 upon x into root x square minus 1. Y cosec inverse x. Minus 1 by x into root x square minus 1. While writing sec inverse, which is same as it is not c, its sign is plus. Yes, my friends. These are 6 inverse trigonometric functions. 6 inverse trigonometric functions and their derivatives. This is one pair. Sine inverse, cos inverse. What is their derivative? 1 upon root 1 minus x square. In case of c, minus sign. What about another pair? Derivative of tan inverse x. It is 1 by 1 plus x square in both cases, as cot being a inverse trigonometric functions that starts with the letter c as a negative sign, minus. What is third pair? Sec inverse and cosec inverse. Sec is with positive, cosec inverse is with minus. What is the derivative? 1 by x into root x square minus 1. Yes, my friends, these are 6 inverse trigonometric functions. I write because next comes examples, my friends. Yes, my friend. First pair is derivative of sine inverse x with respect to x equal to it is 1 by root 1 minus x square. Second, instead of d by dx, I use the letter capital D operator, differential operator. Cos inverse x. It is, my friend, minus 1 upon root 1 minus x square. This is one pair. I make it a separate chamber for them. Separate it is. Next is derivative of tan inverse x. It is 1 upon 1 plus x square. Next, derivative of cot inverse x. Cot inverse x is minus 1 upon 1 plus x square. I told my friends, same with a negative sign, difference in minus. This is second pair. Third pair, derivative of sec inverse x. What is it? Plus 1 upon. It is x into root x square minus 1. Sixth is derivative of cosec inverse x. Cosec inverse x, same with a minus sign. It is x into root x square minus 1. X into root x square minus 1. Yes, my friends. Now, these are what? 6 inverse trigonometric functions and their derivatives. Next comes examples based on these 6 inverse trigonometric functions. 6 inverse trigonometric functions. While doing the examples, my friends, you get instead of x, other than x. Instead of x, other than x. Yes, my friend. 1 minute, observe. This I make it a separate. These are the friends which are very, very useful. Yes, my friends, useful for me. Yes. In this note, what I wanted to tell is, yes, we know that I consider to derivative of sine inverse x with respect to x. This is, my friend, 1 upon root 1 minus x square. Yes, what is second? Derivative of tan inverse x with respect to x. What is derivative of tan inverse, my friend? It is 1 upon 1 plus x square. Like that, even you can consider derivative of sec inverse x with respect to x. Yes, my friend, this. You know what it is there. Then what I wanted is, replace your x by fx. Replace x by fx. Tell my friends, what about this? This fx is any function of x. This fx is any function, maybe algebraic, maybe trigonometric, maybe exponential, anything other than x. Anything other than x. Only two things, man. From the beginning I am telling, one is x, another is other than x. If it is x, it is the derivative. If it is other than x, extra is what? Right, it's derivative. Now you replace it. First, therefore, derivative of sine inverse, it is other than x, my friend, fx, with respect to x. Same thing, 1 upon root 1 minus, my friend, x is x, fx is fx, x is x square, fx is fx whole square. Fx whole square. Again, your observation is here. What is the question? Is it x? No. If it is no, write its derivative into derivative of fx with respect to x. In this case, my friend, what is the derivative of x? Derivative of x is 1. 1 into this is same. Therefore, if it is x, we are not writing its derivative because its derivative is 1. We are not writing. If it is other than x, my friend, derivative of sine inverse fx, yes, 1 by root 1 minus fx whole square other than x into extra, this is derivative of fx. Similarly, derivative of tan inverse fx, derivative of tan inverse fx with respect to x. This is 1 upon, same in case of tan inverse, 1 plus x square if it is x, other than x, it's a square. Fx whole square, other than x means you have to write its derivative. Derivative of fx, my friends. Like this, in case of what? Sec inverse x. What is sec inverse x? 1 by x into root x square minus 1. What you have to do? You have to replace x by fx. Similarly, the third one, derivative of sec inverse fx with respect to x equal to, same my friend, this is 1 upon x is fx square root fx whole square minus 1 x is x into root x square minus 1 other than x, whatever it is you have to write square of this minus 1 other than x means you have to write its derivative of fx with respect to x. My friends have written 3: sin inverse, tan inverse, sec inverse, where the expression function is other than x if it is fx. Remember, if it is x, its derivative is 1, we are not going to write. If it is other than x, its derivative is not 1, write its derivative. What about the remaining 3? Cos inverse minus, cot inverse minus, cosec inverse minus. Yes, my friends, these 3 general with minus you have to replace. So I am going to write what here? 1 over 2 general. So derivative of sin inverse fx with respect to x. This is 1 upon root 1 minus fx whole square into what? D by dx of fx. Similarly, second one, derivative of tan inverse fx with respect to x. Tell my friend, it is 1 upon 1 plus fx whole square into d by dx of fx. Yes, my friends, I have written 2. Similarly, with sec, replace x here, write its derivative. Yes, my friends, these 6 particular, this general formula in case of what? Inverse trigonometric functions. In case of inverse trigonometric functions. Yes, my friends. Now I do the examples. I hope the things are clear. Again, they are very simple, no tension, no pressure. Yes, derivative of sin inverse x, we use the definition along with implicit functions. Along with that trigonometric formula, we got the derivative of sin inverse x is 1 by root 1 minus x square. Similarly, yes, my friends, these 3 with other than x, other than x. I have written many. Yes, my friends. Now, examples. These examples you can expect under what? 1 mark question. Yes, my friends. Examples. 1 mark. Differentiate the following with respect to x. Differentiate the following with respect to x. Yes, my friends, these are 1 mark questions. First one, derivative of 1, derivative of sin inverse 2x with respect to x. Derivative of sin inverse 2x with respect to x. Yes, my friend. What is derivative of sin inverse? 1 by root 1 minus whatever it is, you have to write it's a square, 2x whole square. 2x whole square. Is it x? No, write its derivative. Derivative of 2x with respect to x. Yes, my friend. Simplified, it is 1 by root 1 minus 4x square. What is the derivative of 2x is 2, 5. Derivative of kx is k. Derivative of kx. Ax is k. Yes, my friend. Yes, my friend. Yes, it is 2. So we can simplify. We can write one more step. It's 2 upon this, which is 2 upon this. 2 upon this. Yes, my friend. Yes. Second example. Second. Derivative of cos inverse root x with respect to x. Derivative of cos inverse x with respect to x. See, my friend, first you have to write -1 denominator down, square root 1 minus fx whole square root x whole square into other than x, right? It's a derivative. Derivative of root x with respect to x. Yes, my friend. It is -1 upon root square. It is 1 minus x into root x is what? 1 upon 2 root x. 2 root x. If you want, you can simplify it. You can simplify it. See, it is minus 1 upon. I write this 2. Root x with root 1 minus x. Root. What is it? Total root x into this x into 1 minus x. Yes, my friend, this can be written as -1 upon 2 into square root 1 into x minus x into x. This is the derivative of what? Cos inverse root x. Yes, my friend, those formula will apply. The third example is d by dx of tan inverse x square. Yes. My friends, tan inverse f 1 upon first 1 plus whatever it is, it's a square. It is other than x, right? It's a derivative. Yes, my friend. It is 1 upon. Simplify it. X to the power 4. Use bracket. X square is 2x. 2x upon this, my friends. This is how you have to write what? Derivatives. Yes, my friends. Next is derivative of cot inverse. Cot inverse a to the power x, my friends. Cot inverse a to the power x. Look at cot inverse. X is -1 upon 1 plus x square. It is not x, it is other than x. Right, first. Derivative is, my friend, 1 upon -1 y c 1 plus square a to the power x the whole square into other than x, right? It's a derivative. Yes, simplify it. It is -1 upon 1 plus laws of indices a to the power x into 2 is 2x. What is this? Bracket a to the power x into log x. Derivative of a to the power x is a to the power x into log a. This is what? A to the power x. Next is sec inverse. If y equal to, or find dy by dx. Find dy by dx if y equal to sec inverse 2 to the power x. Sec inverse 2 to the power x. Yes, my friend. Dy by dx. I write supportive step d by dx of supportive step. If you want, you can write. Otherwise, no. I write, man, support. Sec inverse 1 upon down fx 2 to the power x square of this 2 to the power x the whole square minus 1 other than x. Right, it's a derivative of 2 to the power x. See my friend, it is 1 upon 2 to the power x into square root. Simplify it. It is 2 to the power 2x minus 1. What is this? Derivative 2 to the power x into log 2. Into log 2. If you wanted one more step, it is 1 by 2 to the power x square root. 2 square is 4. 2 square is 4. 4 to the power x minus 1 into it is 2 to the power x, my friends, cancels. You cancel it. You cancel it. So this is what? 1 by this into log 2 here. Log 2 or 1 into log 2 is log 2. It is log 2 divided by 4 to the power x minus 1. I hope it is correct. Yes, 2 to the power x. Derivative of 2 to the power x is what? A to the power x into log a, 2 to the power x into log 2. This cancels with this. So 1 into log 2 is log 2 divided by 2 square 4 to the power x, my friend. This is related with sec inverse x. Sec inverse x. Next is y equal to e to the power a tan inverse x. Y equal to e to the power a tan inverse x. Differentiate derivative of y with respect to x. Support it is d by dx of e to the power a tan inverse x. Yes, my friend. Derivative of this. What is e to the power f as it is first? It is e to the power f as it is. Is it x? No. Right, it's derivative. It is derivative of what? A tan inverse x with respect to x. Yes. This is e to the power a tan inverse x. Yes, my friend, I use bracket. A being a constant coefficient remains into derivative of tan inverse. Derivative of tan inverse is 1 upon 1 plus x square. Write neatly like this. E to the power f dash, derivative of power a into derivative of tan inverse. Derivative of tan inverse is 1 upon 1 plus x square. Yes, my friends. Write neatly like this. Yes. Another example is an example from the model question papers. All these are very good examples, my friends. My friends, they're all very good examples. Y equal to sin inverse x into root x. Sin inverse x into root x. My friends, you have to simplify this. X into root x. It is x to the power 1 into x to the power half. Laws of indices. It is 1 plus 1 by 2. It is x to the power 3 by 2. This part is simplified. I have written separate, my friends. Separate. Root x half. Bases are same. Add the powers. Simplify. Yes, my friend. This can be written as sin inverse x to the power 3 by 2. Yes. Differentiate. Dy by dx equal to d by dx of sin inverse x to the power 3 by 2. Yes, friends, write its derivative now. Write its derivative. Equal to sin inverse, see, 1 by square root 1 minus square x to the power 3 by 2 to the power 2. Is it x? No sir. Write its derivative. X to the power 3 by 2, x to the power 3 by 2 with respect to x. That's the simplification. Friend, 1 upon square root 1 minus, down 2 cancels with up, we are left with x cube there, into x to the power n into x to the power n minus 1. It is 3 by 2 minus 1 is half. Right, my friend, it is half. So, what is this? If you write this, it is 3. X to the power half is root x. Denominator 2 comes here. Into square root 1 minus x cube is the answer. 1 minus x cube is the answer. Yes, my friends, observe it. I will explain once again. I told it is an example from the model question paper under 2 mark, not under 1 mark, my friends. 2 mark. 2 mark question. See. Yes, my friends. Find dy by dx if y equal to sin inverse x into root x. Yes, my friend, simplify it because same, x into root x. X to the power 1, x to the power half, add 3 by 2. Substitute sin inverse f, derivative of sin inverse f, support 1 by root 1 minus, whatever it is, it's a square. If it is other than x, write its derivative. Yes, my friend, simplify it. Yes. Root 1 minus, down 2 cancels with up to, you are left with 3 there. X to the power n into x to the power n minus 1, I have written separate here. N minus 1, 3 by 2 minus 1, 3 minus 2, 1 by 2. Yes. Further, my friends, this 3, x to the power half can be written as root x, down 2 into square root 1 minus x cube. This is its derivative, my friends. It is from the model question paper. Good examples. Like this, my friends, you have another 2 or 3 examples appeared in question papers. Yes, my friends. Yes. See the next one. Find dy by dx as it is there if y equal to sin tan inverse e to the power x. Yes, my friend. Dy by dx, support d by dx of, I use this bracket, sin inside tan inverse e to the power x. Yes, my friend. First you have to write the derivative of sine. Derivative of sine is cos. Then I told you to write this as it is angle into, other than x, man, it is d by dx of this angle. It is tan inverse e to the power x. Yes. Equal to, it is cos tan inverse e to the power x. Yes. Tan inverse fx. What is derivative of tan? 1 upon 1 plus e to the power x whole square. Again, other than x, write its derivative. Yes, my friend. Equal to, it is cos tan inverse e to the power x. Simplify it. This is 1 upon 1 plus laws of indices, 2 into x into derivative of e to the power x is e to the power x. E to the power x. Yes, my friends. It is an example in your textbook. May ask under 1 mark, otherwise 2 mark. It is there in your textbook. Yes, my friends. Yes. Like this, another 2 interesting examples are there. Interesting. Yes, my friends. If y equal to 2 mark question, it is also 2 mark question. If y equal to sine 2 sine inverse x, then prove dy by dx equal to square root 1 minus y square upon 1 minus x square. It's a good example under 2 mark question, appeared even in the question paper also, board exam appeared even in question paper. If you differentiate like this, derivative of sine is cos, it becomes lengthy. In this case, what you have to do is, you bring this sine this side, given y equal to sine of 2 sine inverse x. Bring this side. Sine inverse y equal to 2 sine inverse x. Differentiate with respect to x. d by dx of sine inverse y. 2 being a constant coefficient remains d by dx of sine inverse x. Yes, my friend. You know, first with respect to y, 1 by root 1 minus y square. Other than x, right, its derivative dy by dx. Other than x, its derivative equal to 2 into derivative of sine inverse formula 1 minus x square into derivative of x is 1, no need to write it. Shift that side, my friend, one correction. It should be 2 there, correction. Yes, dy by dx is, yes, 2 into, shift, root 1 minus y square upon root 1 minus x square, denominator. Simplify, it is 2 into, have a common square root, serves 1 minus y square upon 1 minus x square, which is this, that 2, please do this correction. Therefore, my friends, if y equal to sine of 2 sine inverse x, prove this. Bring sine this side, sine inverse y equal to this. Differentiate with respect to x. First with respect to y, then y with respect to x. Sine inverse y formula 1 by root 1 minus y square into dy by dx equal to 2 into its derivative. Rest is simplification. Shift to the RHS. Simplify. You have same your own. Like this, my friends. One more on the same type. If y equal to if y equal to sine log x, base is not written means same. Then prove dy by dx equal to it is square root 1 minus y square upon x. Square root 1 minus y square upon x. Yes, my friend, given, right, y equal to this. Bring this side. Sine inverse y equal to log x. differentiate with respect to x. Differentiate with respect to x equal to, it is d by dx of log x, my friend. First, with respect to y, 1 upon root 1 minus y square other than x, right? It's a derivative equal to, derivative of x is log x, derivative of log x is 1 by x. Simplify, dy by dx, my friend, shift numerator 1 minus y square upon x, which you wanted, same as this. These two are similar friend examples, method, everything is same. The only change is instead of 2 sin inverse x log x, even they may give another one here, like this, my friends. These two are very good examples, standard examples. Last one is this. If y equal to sin inverse cos x, then find dy by dx. Yes, my friend. In this case, I hope this example is clear. I think you have copied this also. Sin log x, bring this side, derivative, write the derivative, simplify, bring to RHS, down, up, down is down. This we wanted it. It is a slight change here. Yes, my friends. In this case, to find its derivative, again you have to go back to our results, man. What are the results, my friends? One is, again go back to 10th standard SSLC. You know it. What you know? Sine of pi by 2 minus x is what? Cos x. Therefore, from this cos x is sine pi by 2 minus x. Yes, my friend. To change from cos to sine, what is your observation? Replace your x by pi by 2 minus x. Pi by 2, 90. Change. Sine changes to cos, cos changes to sine. Similarly, I have here tan x. I want to change to the cos. Replace your x by pi by 2 minus x. Similarly, I want to change sine x to cos. What is x? It is pi by 2 minus x. Yes, my friends, we have to do the same here. Right. Given y equal to sine inverse of cos x. Change cos to sine. Why? We want to make use property. Yes, my friend, it is cos to sine. Replace your x by pi by 2 minus x. Property of inverse trigonometric functions. Sine inverse of sine theta is theta itself. This is pi by 2 minus x. It is your y, my friends. Now you differentiate with respect to x. Y. dy by dx equal to 0. Minus 1. What is the answer? Minus 1. Similarly, my friends, do this one or two examples. Diy y equal to cos inverse of sin x. Write in terms of cos. Y equal to tan inverse of cot x. Same, converted. Y equal to sec inverse of cosec inverse x, converted. My friends, do it yourself, use the same. Use the same. Yes, my friends. On inverse, what I have done? First, okay, we got the derivatives of all 6 inverse trigonometric functions. Yes, my friends, this. Then, replacing x by fx, you know the method explained. Then I have done some examples, my friends. These examples really very important under 1 mark, 2 mark questions. Under 1 mark, 2 mark questions. Yes, my friends. This is some examples. You have few more examples on inverse trigonometric functions. That part I do it in the next video. Yes, my friends. Thank you very much. Good day. Thank you very much.